All right, so in this problem, guys, it's very, very, very similar to the problem that we saw before where we're given mass and asked to find your empirical formula. However, for this one, we're given percents. So here we're given 40%, 6.71%, and 53%. To which you say, well, that's really, really hard because how can I find the actual amount in grams of carbon and hydrogen and oxygen if I don't know how much the original sample had, the entire sample? And that's the beauty of it. Okay? We can decide for ourselves how much we want. So for example, if I assume that this whole sample, that the 40%, the 6.71%, and the 53.3% of oxygen came from a sample, a compound that had a mass of 100 grams, so our entire compound had a mass of 100 grams, what we can then assume is that 40.0 grams of that came from carbon, 6.71 grams of that came from hydrogen, and 53.3 grams of that came from oxygen. And so all of a sudden, even though in this problem we're not given grams, we are though. Okay, so you can just assume the percents are basically the same thing as grams if you make the assumption that you start off with 100 grams, which you totally can do. So I'm assuming I start with 100 grams. So I'm going to have 40 grams of carbon, I'm going to have 6.71 grams of hydrogen, and I'm going to have 53.3 grams of oxygen. Alright, so now what I need to do, as in the original problem that we worked on for empirical formulas, the first thing I have to do is convert this to moles. So I'm going to crisscross swoosh this. I'm going to convert to moles, so I need to put grams on the bottom. I need to put moles up top. Okay, and so what your job is to do is to determine what the atomic mass of carbon is. And if you look at this, if you look at your periodic table, you'll find that your atomic mass of carbon is 12. So I'm going to put 12 on the bottom because it's 12 grams for every 1 mole. Okay. And so what I'm going to do is I'm going to take 40 and I'm going to divide it by 12. And what I get for the for the number of moles of carbon is 3.33. And I rounded. That's fine. So I've got 3.33 moles, and I'm going to put carbon behind it just to keep my head straight. Now I'm going to crisscross swoosh again for hydrogen. I'm going to put grams on the bottom to get rid of them, moles up top, just like I did before. If you look at your periodic table, what you'll find is that the atomic mass of hydrogen is just 1 for every 1 mole. Okay, 1 gram for every 1 mole. Therefore, my number of moles of hydrogen is 6.71 moles. Pretty nice and easy. Alright, last one. I'm going to crisscross swoosh. I'm going to put grams on bottom. I'm going to put moles up top. What you'll find is that the atomic mass of oxygen is 16. If you look in your periodic table, for every 1 mole. So I need to take 53.3 and I'm going to divide that by 16, and what I find that to be is 3.33. That looks very familiar to what carbon is. Alright. So I'm going to write this out really quickly. Now, order, honestly, it does matter if we're going to be a really advanced chemistry class that's trying to write the compounds. What I'll try and do for these problems is make sure that they are written correctly in the order that they need to be written. So carbon's going to go first, then hydrogen, then oxygen. So you don't have to be doing any guesswork. Okay? So I'm going to put carbon first with its 3.33 moles. Then I'm going to put hydrogen with its 6.71 moles. And then I'm going to put oxygen with its 3.33 moles. Remember, your next step that you have to do is divide by the fewest number of moles, which in this case is 3.33. So I'm going to divide all of these by 3.33. 3.33 and divide that by 3.33. Alright, and so what you end up getting for carbon, it's just going to be 1, so I'm not going to put anything as a subscript. If I take 6.71 on my calculator and divide it by 3.33, I think what you'll find is that you get pretty close to 2. So it's going to be CH. If I can easily round it down, then that's fine. So I got on my calculator 2.01. Yeah, that's pretty dang close to 2. Now, if it were 2.5, no, it's not close. And we'll discuss what we do at that point. But right now, it's pretty nice and easy, and then for oxygen it's going to be a 1. So this is the empirical formula that we get, and we're done. Not too bad. Okay? So with percents, guys, really nice and easy. You can even assume it's the same thing as saying just grams, so 40 grams. as long as you assume that your original compound had 100 grams of it.